kind of talking about the end of the year here before we get rolling. You guys have about a month left. We're going to do finish up talking about sequences and series and do a test on that. That'll probably be the end of next week. That'll be the last test of the semester. We'll continue on with some other stuff after that, maybe some vector stuff. Anything we do after that last test would be exam-only material. Everybody cool with that plan? Today I have 20 to 30 minutes of talking to do, and then I'll stop and let you guys work on a second Delta Math assignment, or if you haven't finished the first one yet, you could start on that one. Today's going to wrap up our sequences talk. We'll do some in-class practice, have you guys come to the board and do some stuff. Sequence related next class, and then we'll do series the class after that, and that'll wrap. So Friday this week will be the last topic. We'll take a review day and do the test next week, and that should be that. Everybody cool? All right, you ready to roll? Oh, that is embarrassing. Sound like one of those screaming goats. All right. So last time we had talked about sequences in general. We talked about two specific types of sequences, arithmetic and geometric. What is the key feature for an arithmetic sequence? There's a constant common difference. So the pattern between consecutive terms is constant, either addition or subtraction, right? Like +3 + 3, -1/2, -1/2, -1/2. Everybody's okay? The other type was geometric. What's the key feature of a geometric sequence? There's a constant common ratio. That means it's like repeated multiplication, right? So like times 2 times 2 times 2, or like times a third times a third times a third, something like that. Everybody's okay? When we talk about a arithmetic sequence, that's the same as what kind of function? Just like a linear function. So you can, anything you could do with a linear function, you can do with an anything you can do with an arithmetic sequence, you could do with a linear function, right? When we talk about geometric sequences, that's the same as what type of function? Exponential, right? If we look at that explicit formula for a geometric, notice that the n, the independent variables in the exponent, just like an exponential function would be. So again, arithmetic, linear, geometric, exponential. That's the key to remembering what to do, because the same thing, we can treat them the same way we did like linear functions and exponential functions, both of which we'd spend some time studying. All right, so the explicit form for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1, where a sub 1 is the first term, r is that constant common ratio, a sub n is like the dependent variable, and n is like the independent variable, just like a function. The recursive form is a sub n equals r times the previous term, but we have to state what that first term is so we know when to start building that recursive pattern from. So let's take a look at an example here and practice writing the exponent or the explicit and recursive formulas for this sequence: 3, 6, 12, 24, 48. First thing we should do is determine what type of sequence it is, because the formula we'd write for arithmetic is very different than the formula we'd write for geometric. If I look at those terms, what pattern do we see? 3, 6, 12, 24, 48. Yes, good. Times 2. And what does that tell me? that this sequence is geometric, and the R value for that geometric sequence is 2. Everybody's okay there? So my explicit formula is a sub n equals a sub 1 times r to the n minus 1. Well, we have a sub 1, and we have r. And we're done. Very easy, right? Okay. Our recursive formula, a sub n equals r times the previous term, and then we have to give a sub 1. So what is the r value here? Well, that was 2 times the previous term, and the first term here was 3. So there is my recursive sequence. Very easy to write these from a list of terms, right? Does everybody feel all right? Okay. What if we ask you to write the geometric sequence whose third term is 1/4 and whose seventh term is 4? Now, when we gave you the same kind of problem with a arithmetic, it was relatively easy to pull the d value from this because you can just use slope. Here, to solve for the r value, it's a little bit more complicated. What I'm going to do is I'm going to form a system of 2 equations. So remember, this is our explicit formula. So I have like an n and an a sub n for each of these. Right? So I can use that to write a system of 2 equations. Is everybody okay with how I form the system? I'm going to go ahead and simplify things just a little bit and write them in a slightly different order. Now, notice that my variables in this system, a1 and r, the operation between them is multiplication, right? When you guys studied solving systems of equations in Algebra 2, the techniques we used were like substitution and elimination primarily, right? Now, when you used elimination in Algebra 2, the terms, your variables, were always being added or subtracted, right? So to do elimination, you added or subtracted your 2 equations. Everybody kind of remember that? Here, because our variables are being multiplied, to do elimination, we're going to divide. Okay? So I'm going to refer to these as equation A and equation B, just so I have a way of describing them in the notes. What I'm going to do is I'm going to take one equation and divide it by the other equation. What I like to do, what I think makes things easiest, is I want to pick the equation with the biggest exponent and then divide it by the other equation. So equation B is to the 6th power, equation A is to the 2nd power. So I'm going to do equation B divided by equation A. So if I divide them, I'll divide the left-hand sides together. And then I'll divide the right-hand sides. Is everybody okay there? If you look at that left-hand side, what do you notice happens? The A1s cancel. And can I combine r to the 6th divided by r to the 2nd? Yes. How do I combine them? Yes. We subtract the exponents. And then I just need to do 4 divided by 1/4, which is 16. Everybody's okay there? So that gets me down to an equation and to a single variable. How do I solve, or how do I cancel out that fourth power on the r? It's going to cancel that out.
Like root to the fourth.
Fourth root, yes. Now, because that's an even root, what do I need to remember?
Plus or minus.
Excellent. So there I get r is plus or minus 2. The fourth root of 16 is 2. You could type that into a calculator. Do you guys remember how to type say like a fourth root into a calculator? If you pick, or press the math button on your calculator, I think it's command 4. Nope, it's 5. Command 5 allows you to put in a radical and type in whatever base you want there. So it's math command 5. Everybody's okay here? So now I need to solve for, now that I have this, I'm going to solve for A1, right? Because that's my second variable. I need to find that. So to do that, I'm going to substitute my answers back into either equation A or equation B. It doesn't matter which one you choose. I'm going to choose to do equation A because the exponent in A is smaller than the exponent in B, and it just makes the arithmetic a little bit easier. Here's the good news, is because the exponent on R is even, even though we have a plus or minus here, it doesn't really matter, right? Is that right? Okay. You guys agree? Because 2 squared is 4 and negative 2 squared is 4, so I just have one answer. Everybody's okay there? And then to get A1 by itself, I just need to divide by 4. When I do that, I get 1 over 16. So now I have my A and I have my R. That's everything I need to write my explicit formula. Now, how many values for R do I have, though? I have 2. I have positive 2 and negative 2. So how many answers am I going to have for my explicit form? 2. Now, the A1 is the same either way. But my R has 2 different possibilities. Is everybody okay with that? And then to do my recursive, what's that? Oh my gosh, I sure do. Let's do that. Thanks, Mark. So my R value was 2. Oops. Or my R value could be negative 2. Is everybody okay with what we did there? That's probably the hardest version of building a sequence, is going to be that kind of question, right? The last thing I want to do is talk about how we can go from explicit to recursive, or recursive back to explicit. Everybody's okay with that plan? So if I look at A, example A, that's an explicit formula, right? Because it's defined in terms of n. What type of sequence is part A? Is that arithmetic or geometric? It's arithmetic. How do I know? It looks like a linear function, right? Looks like mx plus b. Everybody agree? So what is if you remember, for arithmetic function or arithmetic sequence, the common difference, the d, is the same as the slope. So in this one, I have the d. The d is just 7. And then I need the first term. How am I going to find the first term? Well, guys, I have the explicit function, or the explicit formula, right? I just plug it in, man. Easy peasy. And we are donezo. Is everybody okay with that? Okay. This one, we're going to go from a recursive back to the explicit. First thing I want to do is look at the formula and decide whether this is geometric or arithmetic. If I look at this one, it is geometric. How can you tell? Because of the times, right? So I know that the r is 3/2, and I know the first term is 10. And we are done. Super easy, right? So that at this point, we've outlined how to go from a sequence to an explicit or recursive formula for both arithmetic and geometric sequences, from 2 terms to the explicit formula or recursive formula for both arithmetic and geometric sequences, right? How to go back and forth between explicit and recursive formulas for both arithmetic and geometric sequences. And this is our stopping point for today. Look at that. I was 2.5 minutes early when I said 20 or 30 minutes. That's not bad, right, guys?
That's a good estimate.
Yeah, not bad.
Over under.
We went under today. So I have a second Delta Math assignment for you guys. So both these 2 Delta Maths are going to be due this Sunday. So if you haven't finished that first Delta Math, that one's pretty short. Your second Delta Math is a little bit longer. But as you guys have seen with the example problems here, a lot of these should be relatively quick, right? Like distinguish between arithmetic and geometric sequences. What's going on here? Arithmetic or geometric? Geo. Because the common ratio is 9. You know, like that took 10 seconds, right? Like some of these are going to go real fast because it's just not that big of a problem. Go ahead, Max. Sure. So you have to write that, you know, like find the 14th term. So you just write the explicit formula and then plug the 14 in and so on and so forth. It's usually not that big of a deal. Okie dokie, artichokes. All right. Please, please, please pull out your tablets, fire up your Delta Math. Let's make some progress today. Try to knock out at least one of these assignments. Should be no problem knocking out that first one. I think Delta Math's estimate, which I think are often overestimates, put that one at like 32 minutes or something for the first Delta Math. I think that probably most of you can finish it in 20. But, you know, if you make a couple of mistakes, that obviously slows you down a little bit. But this should be relatively straightforward. If you have questions on stuff, feel free to come up and talk to me and ask questions, and I'll walk you through or talk you through whatever you're doing. Otherwise, that's it for today. Reminder again, tomorrow we're going to do some in-class practice with papers and at the board, and you guys will move around and that kind of stuff. We'll probably split you guys into, I think we'll do 4 groups because I have 4 different papers and we'll have 4 different like stations, and assign each group a quarter of the problems to work at, and we'll just kind of rotate from station to station to station, where you get a chance to like see me and talk to me or whatever. And how's that sound? Get some individual feedback relatively quickly. Okie doke. Okay. I'm stopping. You guys are working.